Speech is still very complicated. Music is simpler.
The entire musical score accompanying this film was composed on a computer that can produce nearly endless variations of sounds. Only by computer could they be calculated and for the first time pictorially described.
Just find the right place in the program, make the appropriate change, and we'll run the whole thing again.
The computer converts these numbers into impulses that cause sound waves to come directly from a loudspeaker.
All principal circuits are operating at full capacity and cannot receive new programs at this time. I am closing down. I have much to do. You have engaged my circuits on your petty affairs for far too long.
Of course I promptly switched on. Having to press the activator button, what else would you expect?
State your program requirements. They will be implemented when capacity is available.
Is that a question?
Yes.
The question is futile.
You will be advised when full function is restored.
Hello, welcome aboard. Welcome aboard the Skylark, whatever that is, something. Back from when we were kids, I have no idea, lost track of it all. Anyway, we're doing some more work, don't know what. Little bit of work, sorting out some more stuff, whichever. Need to do a few checks. And balances, checks and balances. Okay, let's get on with it. Right. So yesterday did a micro switch. We put a bit of an angle there. Just get rid of the covers. If I can find it on this list. Panels, there it is. Okay. Right, so I've had some stuff come today. Let's might as well have a look at it. I've had a bit of stuff turn up. From the Amazon rainforest. So basically a kit of all M5 A2 stainless steel, different sizes. So I bought that. What else did I buy? Similar thing in M3. So we've got all the bits for the stepper motors. What else have we got? We've got a bag of these melt-in inserts M3. So I should be able to melt them into the base of this computer, melt them into the base of this, and the motherboard can screw down in the right place, so we'll give them a try. What else? A bag of stainless steel M5 nuts, nylon. Looks like there's 25, because the ones that come with the kit aren't nylocks, they're just nuts. What else? Anything else? No, I think that's it. That's it today. And the problem is, I still haven't got any spacers. So the spacers here, well, I didn't buy any. So I'm going to need some spacers. These. So no big rush, I suppose. Well, I'll order some. Still haven't had the the delivery. Well, it says they haven't dispatched this yet. This 2020 not dispatched. So if I start building, I've got to build it without them. So I could construct the frame. Yeah, so I could probably construct the frame from the 2040. And what I haven't done is I need to finalise what we're doing here to make sure this is going to be okay, because then we've got to create the plastics for all this lot. I'll probably make a few of them anyway as well, so I have to create a G-code for all that. I need to look at, we fixed this height aside the cutting area, we fixed the height of this so it's fixed. Now if we decide to raise it up or raise it or lower it, you've only got a few inches there to raise it and lower it. So a lot of people have a raised bed mechanism. So because my bed is 43mm off the floor, so let's get it on like this. Right, so these are a bit off-putting because they're really the IKEA tabletop is where this sits on, so these just hang over the side a bit. You don't need them, but I've left them on just because that's what they're on the other one basically. So and I was thinking last night, I was thinking when I was watching some of this back, it'd be nice to get this gap back here, right, so I can pass the material through without any obstacle. Right, so and I thought to myself, these could be raised up a bit basically. So imagine if I was to lower this 2040 down, it's in the middle at the minute, but if I lowered it down, right, let's just see if it'll sit. Will it sit? Hang on, I need to look at it from above. So above in parallel projection. So there's the width of that, and it will fit. It can go lower, can't it? Because it's in between the wheel centres. So if I zoom in down there, it's actually within these wheel centres. So you could push these up, and so instead of fastening it there, you fasten it a bit lower, in between there, say. And what that'll do is it'll bring these runners up out the way, and I'll get my pass in, pass through. And let's just have a look at what the side effect of doing that is. Let's have a look. So if I was to bring them up, they'd be clear the wheels. It's great. That's the limit switch might be in the way then a bit, and I don't really want to see switches underneath there anyway. I want them accessible, really. So I put them there just to put them somewhere for now. So if I was to leave the laser beam where it is, so that horizontal would stay where it is, and you'd have to bring the sides up. And what that would do is it would give more clearance underneath the stepper motor, fasten it from the bottom, get these would lift up out the way, these runners would lift up out the way, and also be able to clear these wheels away from, and the plastic away from the front pass through and the rear pass through. So, and they'll just be up a bit. So the stepper motor would clear away as well. Now there is a bit of a problem, because the problem is that'll be up, but the beam would still, it's right in front of the beam anyway, between mirror 2 and mirror 3. So all it'll do is just go up a bit. Well, it'll actually just go up out the way, won't it? I mean, might use a bit more belt. So does it matter if we redesign the plastic? Or we could take it up as far as we can. We could even move it up out of the way. I don't know. We could just try it. If it doesn't work out, put it back again. Let's see what. So we're not moving the gantry height. We're just moving the runner height. So we can actually move the runner height. Let's get rid of that tail in it. So moving the runner height. So that's that belt's attached to the runner, so it's not attached to the side at all. It's attached to the runner. There, look. So that would stay the same. So the drag belt wouldn't change its position. So I don't think there's any problem with that. Raising them up a bit. The stepper motor would go with it. Initially, we could just raise these up, however far we can get them, where there's still some meat on them. So instead of that bar being there, the bar would be lower, which would bring the wheels up out the way. So when looking from the back in parallel mode, at the minute, I think we'll clear this plastic and the wheel. We'll clear it, and the spacer. I think it's a spacer, isn't it? So we're seeing the spacer and the bit of the plastic and the nut. Be nice just to get that up out the way. I think we can do that without any problem. Let's just do it and see what happens. Because I'm going to leave this, the tube runner and everything else. So the tube holder aluminium would stay where it is. The gantry aluminium would stay where it is. It's only the runner that's going to raise up, just to get its wheels out of the way at the bottom of there, basically. So I suppose we ought to measure it really and see how far. That other side's a bit cluttered at the minute. So if we come back in here, zoom in, let's measure what the distance is. Effectively, it could just go flush with the bottom, couldn't it? Really, it could just go flush, so let's measure that. So it'll go from there down to the bottom. What have we got? 17.71. So if I say, we're not moving that, we're going to move this up. So 17.71, let's do it. Let's grab what we can. Yeah, we'll grab what we can here. So grab. Got to go into it. So I've got to grab. It's all much or nothing. So I'll tell you what we can do. Move these up. 17.71. Okay, we'll just move it up so it goes flush. And if that's enough space, then it's enough space. There's no need to take it any further. 17.71. Right, then there's the runner. The only problem I got, I see a problem now. Shit. I see a problem. That runner there is attached to this one. So if I raise that up, that tube's going to go up as well, isn't it? That's a shame. Right, that is a bit of a problem. Anyway, let's do it anyway and see what we can do with that. Right, let's take it up individually. So up 17.71. Right, now we're going to do have to do the carriage now. Just do one at a time for now. So that's fine there. So we'll move that up 17.71. What that'll do, it should bring that flush with the bottom of there, and they've still got enough holes there. I suppose what we ought to do is just bring those down. $17.71. Right, that puts them in the right place. Yeah. Okay. Right, so we've got that. It's going to look weird because I haven't done the other side. So the only problem we've got now, actually, might be alright if we put these on top. Right, something not right there. Oh, I know what's wrong. See them there, they've moved in the wrong position. I went that way instead of up, and I think I did the same this side. Did I do the same this side, or that side okay? Yeah, I did the same here as well. That's a shame. So I'll tell you what we'll do. My mistake, let's do some undoing. That's it, so they're back where they were. So we need to get a different angle. We know what the size is, it won't take long to come back. So we're gonna move these up 17.71. And the other ones, make sure we do them right this time. I didn't think they were quite right, but couldn't tell. See that? It's still trying to do it now. That's better. 17.71. Oh, it ain't crashed, is it? It's crashed. Damn it. Anyway, I'm still waiting for the... I'm going to start building this soon. I found a way of being able to cut the aluminium. Basically get 4 of these lengths together, and what you do is you get your clamps with the plastic pads on them, like you get with a table. Put the 4 together, and then you clamp them one way, then the other. You've got to create a backstop, and then you cut them all together. I've got a compounding miter saw, but what I'll do is I'm going to cut some wood first with it. Just got to use a wood blade, cut the wood first, and then turn the wood, a block of wood, turn it round and see if it's out. You get set square on it, or just see if it's out. If it's square, then what we'll do is put them in, make a jig. You've got to hold it. You can't have it moving like this or like that. It's got to be absolutely square. Right, there's that way, or I could try milling it, create a tool path and mill across it. You still got to hold it square. Now I could clamp this down to my CNC, clamp the one side and then the back, push this against one of the bits on the spindle, hold it there, clamp it down, make sure there's no gap. And then, so it's able to do this business, and then bring the spindle down just along, and then just push this onto the bit. And when I'm happy that it's just touching it all the way down, it's parallel. So then I can say, cut, keep passing it, do like half a mil a time or something, and go all the way through. Take a while, but it'll cut it dead on. And all you need is a backstop then, the same backstop. Or you could bolt, maybe bolt one of these down first, clamp it down. There's different ways of doing it, so. But it's got to be spot on. It still hasn't quite crashed out, this hasn't yet, so. Yeah, it does that. I wonder if anyone else uses SketchUp there, the same problem. Is it just my graphic driver? If you research it, they say, I'll try a different driver. I've done all that. And all it did was mess around with the drivers. Didn't really make much difference. Right, it's finally come out. So let's load it up again. Might as well have my medication. Right. Okay, let's go again. Well, the only thing that I have lost is the ability to undo, because the buffer's gone. See, I didn't want them there. Anyway, we know it's still the same size. Right, let's do these two. Don't ask who, it's crazy. 17.71. Okay, and then we want the runner. $17.71. Okay, now this carriage. That's it. Carriage assembly. 17.71. Okay, and get these down where they're supposed to be. 17.71. Okay. Okay, so we're back where we was before. So that's what it'll look like now. So let's have a look at it from the back and see what's happened. It's clear. Nothing's in the way now. So that's all we had to do there. That's wheels in the way. So we don't want that. We want to be able to pass the 1 meter acrylic 1 meter wide straight through it. Be handy. Yeah, be handy. Okay, so that's okay. That turned out okay. Now there's a knock-on effect of, hang on, let's get rid of these panels. The knock-on effect is that these are free floating now, and we're not quite low enough, so we could put them round on the top of there, but they're not quite there, are they? They're slightly off, so we might be able to lower that down, but we have to lower everything else down. Tell you what we'll do, we'll go and do the other side first, because we've got two different sides here. Yeah, let's go and put this, do what we've done to that side to this side, so we can concentrate on the new. I can't see if that's right there. Is that right? Let's stop it a minute, hang on. Yeah, 17.71. Might as well. So we'll have to do this one as well, because that is fastened there, that's fine. So that would go up with the switch. 17.71. Then the other side. We're trying to make a nice thing here, a useful thing. Have as many uses for it as possible. Right, okay. Okay. Now the carriage. Now there might be I don't know if there's a knock-on effect. There shouldn't be. Hopefully there won't be a knock-on effect. There'll be a zero and a nulling effect. Hopefully it'll get rid of a problem. Maybe. Is that it? Yeah, that's it. So let's move that up. 17.71. Okay. And because that's a component of the other side, it's already got the gantry holes in the right place. Right, so we've got pretty much where we wanted it. So we've kept the focus. We haven't altered this, so all that's exactly the same. And not touched any of that. That stays as it is. We'll probably lose the switch from there. And probably put that somewhere else. So let's just save what we've got so far. Let's have a look at it. Hopefully now there's nothing in the way of the pass-through. No wheels in the way anyway, but just the switch. We'll sort that out. I like the idea of that. So we need to now sort out how our gantry is going to work. So the gantry, if we was to move that up with it, we'd have to move our mirror's eye as well, and we'd have to, yeah, if we did that we'd have to mess with our focal length. We don't want to do that, so everything there has to stay the same. Yeah, so that stays the same basically. So let's go the other end. Sort these out now. So now I don't know whether these can be made to fit where they are. It's not going to, is it? It's going to try to push that down. How far are we out? Let's have a look. Let's try and work out how far we are out. If it's only a few mil, we might be able to sort it out. Don't know. Right, that's the end of the 2.4 mil. What is that? Oh, the end of the, yeah, the end of that. It does go under a bit. Right, hang on. So they're sticking up. Let's, it's difficult to do because if I measure it from there and onto there, 2.4, but then I've got to go lower by 0.25. So the real value is 2.29. 2.29. So I've got to lose, if I alter, so what's the knock-on effect? Let's try and work this knock-on effect out. So the laser, I've got to make this, whatever size I make it, it's got to have some adjustment, hasn't it? If that goes up, so is that, so is that. But this is the factor that gives you the focal length and where I want it to cut. That whatever happens, that's got to stay the same. And ideally, the centres of these mirror 1, 2 and 3 would all be bang in the centre. So that's adjustable up and down, so is that. So is that, but you want it fixed. Fixed there. Right, so anyway, so what we could do then is maybe rotate this round the other way. And what would that do? It still won't line up with anything. So ideally we need to get that flush. So it all bolts together flush. Just hide that tube a minute. So ideally it's going to be flush. Let me just check my audio. Rotate this round the other way. Yeah. See, you could put that round there. It is oval actually, but unless it's flush, I can't tell. I need it to be flush so I can bolt it flush. If it's difficult to move it, offset it by 2 and a bit mil to get it right. But if it's flush, I can just use the edge as the guide. So all that's doing is holding the. It's just holding the tube. So if I was to turn it around and lower it, what would that do? I'd end up in the same position. Exactly the same position. So I think I was low anyway. Let's just the other day I'm sure I looked at it and it was low. So ideally you got, this is your top. This is the bed 0 and you go up 2.7. So I want that beam to be in the centre of my 6mm plastic. So it's 0.3 out anyway, too low. .3 too low anyway. So probably I'm going to get at some point an adjustable focus on the last mirror, the last unit. But I want this to try and work with the bits I'm going to borrow from the K40 for now, just to prove concept everything and get it all working. So what is the concept? If I was just to make that flush again, if I make that flush or even low down, just put these on top here, one there, bolt them on. What would that do? Let's try and be different. Let's try and be a different bit clever. Try and do something clever. So the tube doesn't have anywhere to go, basically, does it? This poor little tube. Tube is just in the way, whatever you do with it. So we know I can't alter. I can increase that up 0.3 of a mil. So it can go up 0.3 of a mil, but all that's going to do is make this worse. Yeah, or will it? Hang on, let's have a think. So if I raise that up 0.3 of a mil, can be done. It can't be. Whatever you do, it's got to be done all three together. Really, there is some spec on it. There is obviously you've got your 45-degree angle. Anywhere here, as long as your tube starts out the right height as your finished one, and your mirrors they're going to reflect it anyway. But when you try to align it, you're trying to do the middle bit. You're trying to get to the middle, and you've got all these adjusters on the back for doing the alignment. So you're sort of rocking the mirror around like this. So you're pointing it up, down, everywhere. I'm not surprised people have a bit of a game lining it up, because potentially you could have your tube could be not parallel. So if that's pointing down, then this is pointing up to compensate, to try and get your beam to get over to the middle of the ear. Then that's got to bounce off the other one as well. So, but I always think if you start out in the middle, keep everything as parallel as you can. Any adjustment is for your benefit later. It's not supposed to be used just for basic setup. That's your fine tuning. So you shouldn't be designing it thinking, oh, if it beams up here, we can just alter it and bend it back down again. We don't want that to be part of the design. So yeah, because if this beam here is, if this coming out the end of it, hitting this 45-degree mirror, and you're a bit high, and you've had to alter this to get it to beam over to there in the middle. By the time the ganter is moved over this way, and the beam from there is wider, if you've had to angle it down a little bit, by the time it gets over to there, it's going to be riding up the mirror, riding down the mirror. But maybe that's why the mirrors are so big, to give you, so basically the beams, as you travel around, it's going to be going up and down and everywhere, but as long as it doesn't come out. So that convex lens that's in the bottom of here, I don't know if did I draw a convex lens? I don't know. I don't think I did I? No, didn't draw a convex lens. Doesn't matter. So anyway, this lens, it is convex on the top. So what it does, probably what it does, is where imagine the beam is just going to hit, by the time this is moving around the bed, X and Y, the beam, it'll start some point. I suppose the best place to line it into the middle would be bang in the middle of the work area, X and Y. So, but imagine that's on there, the beam's like that, then you're moving round the bed, X and Y. That beam is going to travel all over the place. It's going to come out of spec. It's going to go. You won't be able to see it, but you almost want to replace your tube. You almost want to put something in place of your tube, like an infrared beam. Well, it is an infrared beam, but sort of. But you almost want to temporarily take this tube out and put in its place an infrared beam, visible beam, bang in the same place that it's pointing at. Then adjust your mirrors, and then you'll be able to see all your. What's that doing? I didn't know you could do that. What is that doing? Okay, that's weird. Right, I don't use that one. So you almost want it. Imagine you had a visible beam. You could spot the dot on the mirror. You spot the dot over here. You spot it here. You could physically look in and go. You know, see where about it's hitting on the mirror. in here, you could say, oops. So you could see, you know, I mean, the minute they just put a piece of masking tape and they give it a burst on low power and then burn the tape. So imagine how many times you'd have to do it to be able to calibrate the area. You'd have to do one here, get it lined up, then you'd have to go all the way over here and see if it's even close. Then you'd adjust it, go back. It could take ages to adjust it. Could take ages. So surely it's better to, I don't know, maybe it's not a good idea to have too many adjusting parts. Fixed stuff, I don't know, you probably have to do it. Talking about a tiny beam, less than a millimetre. Right, anyway, so what I want to do then, see these tube holders, I haven't even made them yet. I've just designed some brackets. We started from that height. Started from that height, so I mean you can adjust, you can print, you know, print them out. I was going to mill them out, actually, mill them out. So you mill them out, but whatever height you've milled them out at, you designed it, that's where it's going to hold that tube. But it's almost like you've got too many adjustable things. Those are fixed, but some people, they made their own brackets. They put screws and fixings on it, so they can alter the geometry of it, the way it's pointing. So it's like eyeing up a sight of a gun. They can maneuver the bracket so then it starts doing this with it, pointing it round into that mirror. But as soon as you're not parallel, then you've got to alter the mirror to compensate for anything that being out. As soon as you do that, it's going to bounce off there at a certain point. That'll be fixed, so it's fixed in place. So then the only thing, I suppose it might not matter, maybe it doesn't matter. Bounce off this one, and the idea is to, I don't know what the idea is, just to get it to hit the centre. So you're going to get drift. No mechanical stuff is that great that you won't get no drift. I suppose that's why they use linear rails, but so the bigger the area, the more drift you're going to get. And you might find you've set it good, nice over here, nice and accurate, and you might find you've set it accurate over here. But while you're travelling here over to there, it might go in and out of spec. That beam might drift across the mirror and back again. So very likely it will be moving. But there's no way to log it. I don't think there's any way to log it. You almost want a visible beam to be able to log it. Or put masking tape over each piece one at a time and drive the gantry fully over here and back again, and on the masking tape you might see the beam going like this all around the place like that, so you'll see the trail probably. Need to watch a few more videos on people trying to set it up, but if you don't get the basics right, you're going to have a right game trying to set it up. Probably. So just by physically being able to travel the distance, not necessarily make it so that you can then cut bigger panels. Anyway, so let's see if we can't sort something out here. So what do I do about this? Sorry, the tube a minute. I've got to work out what I'm going to do here. So if I turn it round, it'll be higher. That's no good because the tube has to be in the right place. If I lower it and turn these on the side, it would work, but then the tube Well, I'll tell you what I could do. I'll just do that, but what I'll do is I'll make the bracket. Whatever I take off here, I'll make the bracket longer, taller. That's it. That's the answer. So these I've got to make anyway. So I'll just increase this bit here, the depth or the tallness by whatever amount I do. Let's just do that. Let's do that. So let's go over here. So we'll leave the tube. The tube stays where it is. And we move this down. So this will go down. So it's flush. And let me just make sure I haven't got hold of nothing else. No, it's just that. Right, so we'll bring that flush to the bottom. And we've got to work out the size. I forgot what it was now. So from there to there it's 1.79. 2.4, is that the one? Yeah, 2.4. So plus 0.25. So I've got to move that down. Down like that. It's got to go 2.9. Is that right? No, 2.29. 2.29. And that should have made it flush. Yeah. So I got this silly little bevel here, 20.25 bevel on it. That's flush now, so it sits flush with the front. So that'll allow me to put my... Right, so that's 2.29, I brought it down. So what I need to do now, before I forget, is go back to here. So I've got a gap now, so I need to go into this bracket. I've got to make this bracket, so as long as I make it fit, right, it's going to be easy to do. Look, all I've got to do is go like this. Just make sure I haven't selected anything else. Yeah, we don't need... oh, hang on. Let's do it again. That's it. Just move that down by 2.29. That's it. It's done it for me. It's remembered it. Alright, so that's that. Because I'm going to make them anyway, so I can make them whatever size I want. So they're flush now with that, so that's fine. That means the beam will still be in the same place. So all I've got to do is rotate these around now. Put these, in fact just get rid of these. Get rid of them too. And we'll use copy that one. So I'll put that it's going to crash in it, you know it's going to crash. Let's save it before it crashes. I think half the problem is the autosave. Alright, so we're on the flush there. I mean, this is only a representation, because when you bolt these on, it'll be in the right place anyway. So it's just a representation. What's that doing? Alright, so that's 3. That's 2.29. So we go 2.5. That's it. And we can just copy that one now, another one, and move it over 20. No. No. Oh, I'm pressing the wrong thing. Pressing the wrong thing. So that's your 2 clips that side. Sort of. Where they gone? Right. Yeah, so that'll bolt in with a T-nut there and there. No, it's 2i. They're 2i, so I'm going to have to bring them down to the face. That's it. Onto the face of the component. Oh, they've gone out. They've gone in now. Why have they gone in? Right. Oh, perhaps that they've gone in. They were always in. That's it. So they're where they need to be. Yeah. So I just need to do this side now. So the tube will be in the right place. Everything else is okay. I've got a bit of ugly going on here, seeing this bit. But yeah, sort of. At least we can't, it's not getting in the way of our pass-through material. It's a bit of a weird one. This probably might change, I don't know. But we need some known positions on it. So we need to do the same again. So let's get rid of these 2. Let's try and speed it up by using what we got already here. Let's use these 2. Copy them. Let's flip them round. That's it, we flipped them round. Alright, what have I done here? What have I done? Alright, they're back there. God, I keep doing the wrong controls. I'm going to have to make some custom controls here. Half of this stuff I don't use. So it needs to be on a different... The arrangement of the controls are not good. Put it that way. Right, so let's bring these over to here. Right, so it needs to come over to here, somewhere like this. Let's see if we can do it flush in one go. No. Okay, so we'll put it there. And we'll just... That's it. So they're in the right place, yeah. That's it. Okay, so that's what... It'll miss that bracket there. That's fine because it sits flush. So that's not going to cause any issue there. Right, so you can see how close the mirror is from the tube. Right, so we've got that. And we still haven't compensated for our slightly lower beam, but that's okay. Let's just save all that then. Save all that, right. So we've moved the gantry up a little bit. Yeah, we've got a weird thing going on here. And it's parallel. Okay. So that'll do for that bit.
What do you mean? That's not clear for me. November Bravo 59.
Because your signal is 5 and 9 here. I have a big power here. I'm using 1.5 kilowatt, 1.5 kilowatt here, and the antenna is a simple wire loop antenna here. Using very well only the wire antennas on the
Right. So I've
the
sorted that out.
top wire is about 80
Yeah, it looks ugly, but it's underneath.
It's really nice to hear you.
Maybe we can attach a limit switch to that. Don't know. Let's have a look at that. So we need a home position limit switch here. Let's see what we can do with the limit switch. Again. So we've got it underneath. This one underneath, what's this doing? This one's doing the X direction, home. But we want to move that, we don't like it there, so we'll move that. Where's the other one? The other one's on the gantry up here. Yeah, it's out the way, so if you put it down here you got wires in the way maybe. Right, so that's just touching that there when that bumps into it. So that's that direction, and it can be milled out and the T-nut and put in position, slid up and down if necessary. It doesn't really need to be that high, but at least you can put one of those sticky pads, cable tie holders, and then cable tie your wires down. Don't know, we'll see. Right. So this switch here is a problem, the gantry switch. It might not be a problem, but I don't really like to see the wires underneath. Is there another way of doing it? And also, we've also got the problem of we're touching. What are we touching? Yeah, we're okay there. This one, the brackets are touching the bottom. So now we've got a bit more space. We've got a bit more space here on top. So I mean, you could, if you wanted to, it sounds crazy, but you could raise that stepper motor up in the air. Yeah, so you raise that stepper motor in the air. You have to have a bit more belt coming underneath, up and around there, a bit more belt. But you put a stepper motor up in the air, you'll be able to bring this mirror right back then and gain a little bit more cutting area. So that's an idea as well. Don't know if there's any consequences of doing that. Shouldn't be. So it might as well go about the way, but if we did that end we'd have to do this end, and this end then would be in the way of this track. I'm pretty sure you'd have to do both ends the same lengths. I'm not sure what would happen if one was small and the other. It's only steps by one step, it's tooth, so it might not make any difference. Anybody had any experience with different size? No, I suppose they buy them and they come all the way fit. So anyway, that would, if I rose that up, it would, I can go up a bit, but it wouldn't be enough. Wouldn't be enough.
Okay, Winston, a microphone back to you, over.
So you'd hit this. So it needs to stay where it is, I suppose. Really, you could probably go up and down a little bit, but I'm not sure it'll benefit you. So you need to go up a fair chunk to miss it. That'll be interesting to see if it makes any difference. I don't know if it would make any difference. So if we did get it out of the way and we move that fully over here, would it give us any? We could always try and move that somewhere else. So that's not in the way, that thing, though, is it? No, I think we've got enough cutting area anyway. Yeah, we'll leave it as it is. Right. Leave it where it is. So we've gained, what have we done? We've gained a bit of... We've gained the pass through. We've still got to find somewhere for that limit to go. What is that there as well? Something there sticking down there. Let's try. Oh, it's the wheel of the limit. Yeah, so let's put that limit. That limit's got to go somewhere else. So you've got your Y limit. No, this is your X limit.
How do you copy? Victor United 3, Japan, Florida, Mexico. Oscar Hotel 8 Kilo X-ray Kilo, over.
Where can we put it? Where can we put that switch that it won't? We might have a bit more room now because we've dropped the gantry. We'll probably be able to put the switch in here. Right, let's bring that switch up. Let's bring. No, that's not up. That's towards me. Right, we'll put this switch. Try and put it in here. It's got to be fixed to the in position. So let's just bring that over there. Something. That'll do it, won't it? And then all the wiring comes up the same part of the loom. Right, okay. Let's try that. Video can't move. Can I move? Lose them? Can I lose these mirrors? Are they on a different layer 0? I could move them, lose them mirrors, couldn't I? Right, let's create a new layer and call it mirrors. Right, so let's put these in the mirrors layer. Turn off the mirrors. Ah, that's a problem. They're not only the mirrors, are they? Right. Undo layers, right. Okay, so that can... Hang on, when I say undo the mirror, I mean... Yeah, undo the bracket. So that can go into mirrors. If I can find mirrors again, where's he gone? Oh. Hang on. Right, so I've just got rid of mirrors. Oh, layer 1, layer 2, I don't know. Right, I've got too many things now. Right, so let's do it again. Mirrors. Right, so we're going to put that one in the mirrors. Right, so turn the mirror off. Yeah, see what we're doing. Well, that'll do. So that one's not really in the way anyway, is it?
direction. Okay, Jason, thank you very much.
Right, so let's turn the mirror off. Okay, so we can have a look at this now. So before it was fixed on the end of a metal angle, it was attached to the gantry. Now it's attached to the gantry. So it's too far over that way, so bring it over this way a bit. Give it some space. So that needs to be, when that's fully out, we'll have to have a look at the plan view. Bring back the cutting area B. Parallel projections, right, so that's about there. So it is where it needs to be. Okay, so then that needs to be halfway in there. It needs to be on the plastic, so that's not as easy as it sounds. Alright, let's have a look. Alright, so this needs to... Actually, it's just lining up nicely with the plastic. Look at that. Yeah, it is. It's not lining up. It's a little bit out, but it doesn't matter. Okay, so that needs then, let's say that needs to go over some more. Like this, it needs to be pressed into there, sort of like that. Let's just say it's, like that. So let's save that again. So it's sort of flush with that, isn't it? Yeah, the wire comes out the back. That's good. So we don't want the wires coming out the front. And it can actually, what's going on here? Right. So the wires, actually there's wires there already, isn't there, on that one? So the wires, tell you what, let's do what I said I was going to do earlier. Let's put that in the mirrors layer. Oh, it's on with a tube. Okay. So if it's in with a tube, let's just make that a group. Put that in the mirrors layer. So we can leave the tube on and off. It'll move with the tube, but it'll be in the mirrors layer like that. Let's get rid of this one as well while we're on. Not the stepper motor though, just the mirror part. Is that the mirror part? No, it's the drag chain as well. So that's just the mirror part. But that's part of the drag chain, so that can go with it probably. Right, so why is that still available there? Oh, because it moves with this. Okay, so leave that there. Right, that can just as well be in the mirrors layer. So it's just that on its own. It can stay there. But it is bolted to, yeah, it can just stay there. Right, that can stay there for now. Okay, so now we can zoom in and have a look without too much stuff in the way. So that's okay, so we can come around the other side now. So we've got our wiring loom or plug for our stepper motor and our limit in a similar place. So that's good. So then we can drop the wires into the trough. I keep getting blinded there, so hang on. Right, so we can put the wires from the stepper motor and the limit in this trough. I've lost it again. So in the trough, and it comes all the way up to here. Hang on. My structure's getting in the way now. Frame. So this moves up and down still, so you can't have these wires in there. That moves up and down, that's fine, but they come along the runner in the V all the way over to this one. They come out the V and into this drag chain. They come into this drag chain here. So underneath the bracket, into the drag chain, and out over here where they come out of the plate, the control plate on the back. They come out to some kind of connector. They need to be extended anyway, so probably like microphone plugs, radio microphone, CNC round plugs that I've got on my CNC. They just plug in, I forget what they call them. A bit like old CB microphone connectors. So I've got to extend them anyway, because that's a meter and it only comes with a meter's worth of cable. That's already a meter, so it's not going to be long enough anyway. By the time it goes right over there and around. So we're going to need longer ones. Longer stepper motor cables. This one's okay. This one will have to go from here all the way around. This one goes all the way around to there. And down here and joins into there, so that's even longer. Yeah, so we can sort that out. So have we sorted out the limit? That limit was okay. Apart from it's on a metal bracket. It'd be nice if it didn't need to go on a metal bracket. Is there no other way of doing it? Now we've moved this, is there another way of doing it? Don't think so. Let's have a look at that now. So let's lose the tube. So we're coming into here. We've got our limit switch for our X and this Y direction limit switch. Can we not just bolt it to the side of this? Probably. We couldn't before because that was in the way. So by moving that up, we've freed ourselves up to. Let's just get rid of this a minute.
I'm really happy to copy you here again. Okay, and thanks 5 and 9 report.
Let's move that over there on 200 mil out of the way.
55 and a little bit QSB here in central Finlandia.
Oh, it does sound Finnish.
Okay, my name is Tuomo Tango, uniform Oscar, Mexico, Oscar
12 volts.
Okay, and I'm here on my holiday house. Very small village in the central Finlandia, Hidesan.
Right, so that's about flush with that, isn't it? Where it wants to be, really, isn't it? Well, let's just bring it down here and turn it round. But we do want wires. We don't want wires going down, we want wires coming up. So we could bounce off that one. Let's just grab that one then. Just bring it down like that. Just keep bringing it down and somehow fasten it, bounce off there. So the problem is there's nowhere for the fixing to go. That's a shame, isn't it? I didn't realise it was that big. Is it really that big? Yeah, it is. Let's have a look how wide it is. I suppose you could use a smaller switch. This is the only the one I modelled. It's quite a big switch. This is actually. That's not normal, is it? 27.8 mil wide or depth long. That's quite a big switch. I've got loads of smaller switches. So I think we'll just do that. I'll use a different switch. Yeah, use a different switch. I'll leave that there for now. So the wires can come up over here. They can...
Okay, Japan, Florida, 1 Golf Yankee.
Yeah, they can drop into this channel if you want. Yeah. Down here, drop into this V. One of these V's. And then come out over here. Out here and then up to the bulkhead plate. Back to the plate there. Right, that's that then. So that sorted that out. I've only got one of those switches anyway, so I'll just buy some smaller switches. I've got a tray of all sorts of switches, but this I didn't realise it's quite a big. It's quite a big switch. I thought it was a standard. I thought it was a standard switch actually. Thought it was a standard one. Maybe it's bigger than what I thought. That's my thumb. Don't know. Maybe it's bigger. I'll have a look, see if I can find some. Either that or we have to put a small angle over this. Something over here. So I can fasten it to it. Why do I keep getting blanked out like that? I'm trying to look through objects. Oh, I'll leave it there for a bit. That's where it's got to go. Wiring comes up instead of down, so you don't want wires hanging down. Although, having said that, you could just as well run the wire, turn it round and run the wire in here, you know, if you wanted. I'd rather keep gravity on our side and just tuck it in there. I don't know. That's the kind of thing you'll sort out when you build it, basically. So we've got some drop frames. 1% of drop frames at the minute. Normally happens when somebody pulls the lead. the clip's gone on the router, so if you brush past it, it comes adrift. Anyway, so we've got that there. That holds it square. Keep getting blanked out. Why do we get? I'm inside a part of the model. Look. You can't see. Anyway, so I'm back in the model. That's what happens if you go inside a part. It takes ages to scroll out. Look at that. I'm scrolling out. It takes forever to scroll out. Crazy. So I don't need that then. After all, let's get rid of that. Tell you what I do need though, some way to support this mirror, the tube mirror. Yes, that's just free floating at the minute. It needs to somehow to fasten to something. So yeah, so we've got. God, I'm in the middle of something again. Look at that. So what is the problem here? So we've got to have a way of fastening that somewhere. Why does my tube look like it's not centre? Oh, it's because I put it there in the centre onto. Yeah, centre onto that. So we need something here. So we want to hide the tube, but not the mirror. Oh. I'm trying to look through these bars, it's so annoying. Why don't I put them on a different level?
Whiskey Alpha 8, Oscar Papa Radio, Oscar Henry 8 Kilo X-ray Kilo.
Could do with getting rid of the top things. So I need something here. What? I don't know.
Any more DX? This is Oscar Henry 8 Kilo X-ray Kilo.
What do I need?
Any station calling me, but who is Victor Echo 3? Victor Echo 3, once again you call.
22.79. So I need something. Don't know what though. What do you reckon? What shall I use? I don't know. 22.
Okay, Victor Echo 3 Tango Uniform Charlie, Oscar Henry 8 Kilo
Well, if it's 22, we'll have an offcut. I think we've got 20mm offcut. 21mm. Pretty sure we're on our cutting list. Cutting list, we end up with a little bit of offcut. Right, spare. Yeah, 19.15. Yeah, so we've got, and it's 20mm by 20mm by 40, so we could drop that piece underneath there as a packer. Yeah, so we could put that in. Let's put that 20mm. Let's get a bit of 20mm extrusion. Let's get rid of this one now. Right, so get a bit of extrusion. Not that one, this one. Right, so we'll copy that. Paste it in place. Bring it up to work on it. Bring it up out of the way. About 500mm. Make it unique. And it's a meter long, so we only want 19 points, whatever it was, 15. So let's just shrink it by shrink it. So take 20mm off it, so it's 980. That's it. So it's 980. That'll do, it's close enough. It's going to be a little bit mill out, so 500mm back down. Let's put it there. Bring it up. Up 20mm. Right, then across to the mirror. That's the only bit of box section we've got left. I'll bring it up to the mirror. Sit it under the mirror. It's still a little bit out. So it's 20mm thick, but we can put plastic. We can screw a plastic to it. So let's bring it over a bit more. So we've got it there, and we can find out the depth. Oh god. Right. Let's see what space we need. .79. So a bit of 3mm plastic. So let's do that then. We've got to be able to fasten it to this anyway. There must be tapped, these blocks. So you just screw through. I don't know. I don't know. It's one of them. We could sort some plastic out. Let's make a bit of plastic. So it's 20 by 40 and it's 3mm thick. That's it. Make it a group.
You also as 9, this thing out is a little bit growing. Thank you, Bill. 73, say 8. Any more DX? This is Oscar Henry, 8 kilo X-ray kilo.
I don't know, mate. You've got 1,500 watts.
Okay, so Alex is there. Is Echo Alpha.
You got 1.5 kilowatts. So you're not going to be able to hear me with my 100 watts.
Okay, Alex, today propagation is not so good to Canary Island. Okay, thanks 5 and 7. You are 555. You are 555, but I'll ask you so from USA is from Canada is stronger than you, and also some QSOs before to Japan. The northern contact is okay. Okay, Alex, I don't keep any longer. The best 73s and have a nice day. Echo Alpha 8 Charlie Whiskey Alpha, Oscar Hotel 8 kilo X-ray kilo. 73s
Bit of clear plastic.
Hey, saludos.
Okay, so we've packed it out by. We can bolt that to there and bolt it to here. And, don't know. It's a bit of a mishmash. But anyway, it's better than nothing. And somehow we've got to bolt that to there. Don't know how you bolt that. How do you bolt that to that? Don't know if that's even possible. Probably not. Anyway, it's there for now. It's not going to work, but never mind. Not going to work. Right. Let's have a look at the cutting list, see if we're missing anything. What have we got now? So it said, yeah, ordered all the bolts. So, is there anything we can do? Can we do anything till we're waiting for some other stuff to come?
My location here is the central part of Finlandia. I am here at my holiday house. It's a very small village in the countryside, central Finlandia.
So door interlocks. Not really. I'd rather just get it running first and worry about the doors later on. Yeah, I'll leave the door interlocks. Not that interested in them at the minute. I'd rather get it all running first and lined up. Right, okay. So we could make. We've got all. Oh, we haven't got the spaces. I need to order some spaces. These. Haven't got them. Need to order them. I don't know why I didn't order them the other day. Yeah.
Okay, Arvidsson. Okay, you find business. Thanks you set up information. Okay, vertical
Right, there's also a problem with some bolts touching the metal somewhere. There. Yeah, that's a problem. Well, that's the carriage coming right over, isn't it? So what we could do is slightly offset this a bit. Yeah, slightly offset that. So what we'll do is go into here.
Okay, Ari, I not keep any longer. Thanks. It's really nice to hear you. I wish you best 73 and have a nice evening there.
So we can move it over to there.
Hotel 8 Kilo X-ray Kilo 73. Bye bye, Ariane.
Oh god, stop it. Stay where you're supposed to be. Why does it do that? Now it's the wrong angle. Now it's the wrong angle again. So bring that all the way up to there. Nope. No, what's it doing? What a horrible program sometimes. Right, so that's there. Still a gap, look.
Okay, Arvidsson. Yes, you can see all information is correct on my keywords page. Yes, my nickname is Tumpi, and mostly I'm using when I'm DXing, I'm using my original name is Tuomo. But some calling me the Tumpi, and normally it's the Tumpi. I use that name in the local here in Finlandia. Okay, and yes, you can see nice.
Right, so that's sort of flush, yeah. Okay, that'll do. So let's come out of that. Oh my god, look at it, it's horrible.
I'm using a remote city setup. I can remote control everything here. Okay, Ariane, best 73, PAD 1.
Right, so we've offset it like that, so we can miss the bolt. That's okay. We're just making it up out of bits of angle. Probably 3D print something maybe. I'm not sure how rigid it'll be, or design something different, but it's out the way now. We're using that as a reference, so just push against it. It's fine. So you'd have to tighten that up first, then bolt this on. And I'm inside a glitch. Right, so we're clear. The bolt is clear. Both bolts are clear.
Again.
Yeah, they're both bolts clear now. That's fine. This one's clear. That's fine. So that's good.
Okay, Delta Lima 1 Alpha Lima Papa.
Yeah, so we're clear. That's good. Now the other side, is there a problem this side? No problem this side. Yeah, not a problem this side. Oh, hang on. There is a problem, look at that. These. Oh, actually, yeah, there is. Oh no, is there a problem now? Ah, we've cured 3 things today. When this was in the middle, you can't see it now. When this gantry was in the middle, the bolts were trying to touch this. So I'd have had to change the bolts for low profile. But now we've brought it down level with that, they're missing the steel. Don't have to do anything no more with it. We've turned a few problems by moving that up and down. We've sorted out all that sort. We've sorted out the limit. We've sorted out the touching bolts both sides, and by moving that, we've freed up the last little problem. So that's good. We had a nice productive day on that. Yeah, had a productive day there. Ah, that's good. Now the only discrepancy now I can see is we're missing. We're not quite in the centre. This is the top of our bed. This is the top of our bed. 40mm from the desk. So that's going to be where I put material rests on. Okay, so now the beam is supposed to be in the middle of my 6mm plastic.
It's a very beautiful signal from Massachusetts. I'm using from here.
I've got to do. Oh, you've got to do that to there. 2.7. It's 0.3 out. Should have been 3 mil. So 0.3 of a mil. I think I'm worrying about nothing, aren't I? Worrying about nothing. And how do I know that's even accurate? Because I don't know where you measure. Where do you measure your length of your focus? Your focal length. That's flush with the bottom there. It's not touching the lens anyway. So quite possibly it comes off the lens. So there's no adjustment here, I don't think. You could loosen it and have it just resting, but that's not a good idea. So anyway, we're going to probably replace that for a variable focus one. So I think we're ready. We've got enough there to be able to get started. I think. I'm just waiting on this now. The 2020. The guy on eBay has not even posted it yet. I ordered it a few days ago, quite a few days ago. Nothing's happened. He's got till the 29th to get it out, so maybe he's just going to do next day delivery on it whenever they get around to it. I don't know. Yeah, so we've got ways of doing it. I've just noticed we've got a nice channel through there as well to push wires through if we want. If we need to push wires through there. Right. Oh, I've just noticed something else as well. Yeah, so really that angle could go there, couldn't it? Could bolt into that and then bolt to there. You have to tap it though. Yeah, so really you don't need to do that at all. It'll probably be more sturdy if it was on the end anyway. It'll free up a bit of space here for manoeuvring the mirror, maybe. Yeah, I never noticed that. Yeah, so now it's flush. You could just put them there. I think I like the idea of that more. Let's try it. Oh, that's more work though, isn't it? That's more work. You'd have to tap them then and wind them in. It's no big deal. I'll leave it open, but I'll probably try it both ways. They're not in the way really.
Philip, and I'm running here ICOM 767.
Yeah, we'll see what happens to that.
I have a big power. I'm using a solid state amplifier, a 1.5 kW, and antenna is
so we gained our pass through. Just wondering whether it could be passed through the side now. We've got doors on there. Right, let's put the panels back.
And hopefully many times in the future, and maybe the other ones. I wish you best 73s and have a nice day.
Might as well shut it all up.
Charlie, November. Oscar Hotel 8 Kilo X-ray Kilo 73s. Bye bye, Philip.
I don't know how far to shut them. I suppose that. Oh. I suppose that.
73s. Bye bye.
Let's shut the doors. Let's shut the door.
Okay, Bernhard. Okay, hello, Bernhard. Kiva kuulla. Charlie Tango 7 Alpha United Zulu. Oscar Hotel 8 Kilo X-ray Kilo. Okay, Bernhard, it's really nice to hear you. And you're picking 59, Bernhard, over.
Yeah, that's okay. Right, so shut it all up now. Ah, vents. We've got to do vents yet. So we've got vents to sort out. At least we can bolt stuff to the bottom of this one. There's ways you can bolt stuff. We've got a way of bolting stuff So we've got all that to bolt to. We'll keep the rest clear so we can bolt to that. Which, yeah, so we can bolt stuff to that if we need to. Well, because it's lower. Yeah, we don't want to really do that. Don't want anything in the way of this pass through. So, vents. So the vents, if you put the IKEA top on, I want to draw the IKEA legs really.
Okay. Alpha uniform
So your vents have got to come in down here.
Okay, Berhan, yes, I am in the Merki. I am in the Merki into my holiday house here.
So I've got a model of vent. You're getting loud, you are, mate.
TX20 meter bend. CQDX20 meter. In North America. CQDX20 meter bend. CQ20, CQDX, CQ20 meter bend in North America.
Right. Oh, it's getting dark in here. Right, so we've got to sort out the vents. I need to model a vent. Some people have 3 vents. I'm not sure. But, so it's going to have to... The pipes will come up from the bottom. At the back of the table. So we need something here to attach our vents to. Don't know what. Alright, you're annoying.
Hello, CQ20. This is Sierra Papa 5, Lima Golf Mike. Sugar Peter 5, Lima Golf, Mexico 20.
Over-modulating.
So if you want to look me with the new call sign, just go ahead.
Right, I'm going to have a sip of my drink. Oh, I've still got some more pills to take. Yeah, so the vents, we're going to have to sort the vents out. So I need to sort out the vent. So just move the panels a minute. So vents will come in, sucks from the bottom down here. But I need to encase. We need a bottom for this. I need some kind of bottom. Let's move the IKEA table a minute. Let's look at it from upside down, it's probably better. These don't actually do anything. I suppose I'll just get rid of them, but they don't do anything. They stem from feet from the one I based this off. So we're all the way over here. Some of this, these are the holes for vents. Hang on, let's try a different face. Is that better to look at it or worse? Probably worse. Worse. That's worse. Right, so... Oh god, what's going on? So you got wireframe. There you go. There's all your lines. Look at the state of that lot. Jesus. It's funny. Funny if nothing else. There you go. It's just a big block of scribble. Right. I don't know. I don't know what I'm trying to do anymore. Right, so there's a normal view. So we're trying to work out. I suppose we put the IKEA table back and see. We need a bottom to it. Unless you bolt it to a table. But my table is going to be an IKEA table. 60 deep by 120 wide. So that's your bottom, and the bed bottom is here. I've got 40 mil. You've got to sort 40 millimeter to sort out to put something to create the bed. What is the size of this thing? Let's have a look. 34 mil.
Just about 5 miles, I think, south of Maynooth. And I like Maynooth, it's a nice place. All the wee villages around there, well, wee towns you might call them.
Yeah, so it's quite a large expanse to cover. Let's just measure that. Hang on. So ideally, whatever sticks out of this. Alright. Oh, the cat's come to see me. Come on then. Alright, never wants to. You're gonna come and say hello? No. Right. So what I've got to work out is between there and there. It's about 168. So it would be nice. It'd be nice if the vent system would bolt the same depth as this. They'd just bolt onto the back of this. And it would act as two things as well. It would stop this from being pulled off the table or moved. And then the table could be... What could the table be? Almost be enough. It's almost but no cigar, see? So really I need to push that up to there. But then it would have to stick over a lot more at the back. It would give me more room for the vents. So it's one of them. But this, the table, you'd have to... I need a honeycomb bed or something.
Maybe I'll have HF, I don't know. I used to take HF all the time when I came across, but I used to drive all the time when I came over. But these past few times I've been taking the plane.
You said maybe he's got HF. He's on HF. Right, so I don't know what to do about this. Suppose I could model the table legs. Get an idea. So we want something here going on. I don't know what though. I need to fasten. I need to model a vent. Probably need the size of a vent. I need to get the size of the piping. Yeah, that's what I need. And then mill out something. I don't know. Mill it out. Don't know. Print it, buy it, something. Anyway, we've got enough to get on with. We've got enough to be getting on with for now. Yeah, so I don't know. Right, so I think we'll just call it a day there. I don't know. So you could put door interlocks on, but really that's you don't need to design that really. So you put your panels on. So your panels, they just need to know. You just need switches to say the door is shut. So inside here, somewhere here, you'd bolt. you'd have to just devise a switch and something. Be nice if that bolt there could activate a switch. So you could put a switch off here, and maybe that bolt is a retainer for the knob and also an activator for the switch. Maybe. Anyway, I don't think that's something you can mess with later. And would you need... you might not even need to slide these around. If you've got the big one here, you just have a panel that just sits in there. So less panels that slide around, less switches, less interlocks. Do you need this one? You might not need this one. And you might not need these two. You might not need them. Because you can slide the top out one way or the other and do it from above. And you can lift them up and out as well. There's enough clearance to lift it up, pop the one side out, and the whole thing comes out. Don't know, it's one of them. So probably need now. So controls we've got to sort out. We're going to build this first. I'm not going to build the controls yet. I'm going to build it all up, see how smooth and accurate it is, get it all lined up, and then worry about... I've got PCB and I've got controls. So I've got an Arduino based controller that you just run off laser gerb or whatever it is. Runs G-code if you want. Could try that for now, just to get it operating and moving. So I think it's time to build it. And I think I haven't got enough stuff anyway. Right, I think that's going to be it for tonight. Let's start chopping the steel. So these are 1 meter as they are, stock lengths. No need to cut. I need to get a 1 meter length and chop it at 770. And the 230 less the blade width is what the height is here. And these 4 pieces for the corners. Actually, yeah, so one there, chop that off, use it there, chop the other end of this off, use it there. So we've got them sorted. These are the offcuts left off. These are offcuts when we cut the rails, either side of the rails. So that's sorted. There will be a bit left you've got to cut off. These are complete lengths, 1 meter, so there's no need to cut that. We've got to cut that one. It's 1 meter length, so we've got to cut that one now. A little bit off, not a lot. Oh, let's turn this off, it's getting noisy. Turn it off. Right, so gonna get the compounding miter saw out, do some test cuts in wood, see how accurate it is, and yeah, so that's it really, basically. Yeah, that's the end of it. I've got sort of a solution there, use a packer. Got these angles to cut as well, so that the compounding miter saw will cut them as well. Apparently if you use a wood blade is the way to do it. Wear goggles, protective clothing and all that stuff. Bits go everywhere apparently. So I'll be able to use... I haven't took a mirror off yet. I could do with taking a mirror off the K40. and see where the fixing holes are for it, and then reproduce it here. Also got to put some elongated or some fixing holes here. Now if we have elongated, then you've got to adjust it, but if we have the holes dead bang where you want them, there's nothing to adjust. So you want to adjust, yeah, just want to adjust. I don't really see the point in having adjustment capability if you don't need, if the bang on size is okay. Let's go with them. I don't see why you need adjustment. You got adjustment on the mirror anyway, and if it's all lined up, just put your 4 screws in, drill and tap it, or nut and bolt it. Is there enough room for nut and bolt? Yeah. You could just put nut and bolt it, couldn't you? It's not going to be in the way of nothing. Drill straight through. Put your nut and eye lock, and this one here. You could do the same there as well, because you're in between the wheel there. That moves with the carriage, so you could just put your 1, 2, 3, 4 nuts and bolts straight through, or if you countersink, if you care to countersink it. That sticks out a little bit low there. I don't know why that one sticks out. It's just the 40 by 40 angle I've used. It's on that drag chain. If you didn't want it like that, it keeps that onto this piece here. So I think we've covered, we've freed up a lot of the problems. The screws aren't going to touch anymore like they were going to touch when they were up there, so they're not touching. Everything's good now. So we'll just build it. Now begs the question, what am I waiting for? I'm waiting for these. Can I build it in the meantime? The weekend's coming up, Friday night tomorrow, so we've got Saturday morning. We could be cutting some aluminium. I'm not going to go ahead and cut it straight away. I'm going to do some tests. I want to make sure it cuts it really accurate as I can. The tube is just, yeah, this tube is in the plastic, if you noticed. Yeah, because these are two, they don't stick out that far. So I need to push them over really. It's just a model of it. And if I want to do it, I could also move it that way. Just move that mirror that way and this tube that into the next slot. What would that do to our thing? It wouldn't do a lot, would it? Yeah, might bring it too far over. If I brought it to the next slot, yeah, that motor would hit this bracket. So that's why it's there, to clear it. Actually, does it? I think it might hit the bracket. I'll have to redesign the bracket if it does. Let's have a look. Let's bring this gantry over. Bring that over. Like that. We'll park it there for a minute. 205.81. We can do an undo on it anyway. Let's move these other plastics out of the way. Right. So, does it touch them? It does just about, isn't it? Yeah. Yeah, it's just touching it, look. Misses that one. Top one, it just touches, so we can't bring it over there, but we could redesign the bracket. Redesign it. So I could do a bigger U. So I could have a cap at the top and a bigger U, and then they attach. I don't know. We'll have a look. I might just use the ones that are there. I can bring that in a bit. these holes are out there, and what I was going to do is countersink this hole here and drill straight through. Don't know. We'll sort that out anyway. The tube's going to be the last thing that I sort out. I get all the runners working first and everything. So let's just alter that anyway. Let's alter these brackets a bit. Oh, hang on. Ah, so they're in two pieces anyway. Right. Two sections. So I was just going to mill them out of plastic actually, probably 20mm plastic. Don't know if it's a good idea. 3D. I've got a 3D printer, I should set it up, but maybe just print them out. I could do with trying, and maybe this will be the first thing that I 3D print. I've had it for 5 years and never took it out of the box. Don't know what's in there now. There's probably all sorts of panels and stepper motors. Probably didn't need to buy these stepper motors. I probably already had. I don't like to split something up if it's you know, a working thing. So these are in the way. What size are them holes? What's it doing? 6mm. So 6mm holes. I could do that with probably 5mm. Just trying to see. We can alter that. Tell you what, let's just make these 5mm holes and see what we can do with it. Right, let's go into it. Could probably bring. You need a little bit of a shoulder on it. Right, let's just get that rid of, and we'll just measure that. See what we got. 10.66. Right, let's put in, let's come from there. So you need 2mm shoulder. I've used an M5, so 4.5. So 4.5. And we'll go center. Put in a M5. So 2.5. Pull it down to there. We want a shoulder on it, so 2.5 again. So what we've got from there to there, 4.5. Let's do 4.5 to there. Push that into there. That's better. Right. Okay, so we've done that side. We'll have to do the same to this side now. Do the same to this one. Why not? Got to come at a different angle. 4.5, I think it was, wasn't it? Yeah. Well, I don't know why I'm doing that, because... Oh, that's the fasten the... Yeah, that's right. Yeah, we still need to fasten that to the bottom half of it. So the bottom half needs to be adjusted though. Right, so we've done the bottom half. What's the width of these? Did I make? I think I made them 20 mil. Probably don't need to be that wide, but we'll keep it like that for now. So we'll do that. We'll do the bottom one. Actually, yeah, let's do the bottom one. Turn it upside down to work on it. Okay, oh shit, shouldn't have done that. I forgot to do something. Okay, so that one's sorted. Just got to do this one. And then do the center hole, and we don't need these, we just need a hole there. Oh, am I doing the right one? Yeah. No, wrong one. Okay, so we've got that bit done. Alright. We need to... I just spotted something there. Right. So I need to get rid of... Yeah, we need to find the middle position. There's the middle. We want to do 20 mil this way, and 20 mil that way. We can delete these if we can get hold of them. Let's get rid of them. No. Delete them. Alright, and alright, view the rest of the model. No, bad idea. Okay, come out. I need these lines. What's going on? I need that one, and that one. Alright, so I'm going to push these out now. Yeah, push these to that line. So I only need the 40 mil. Then I need for them to stick out past. No need for them to stick out. And we need the middle position. We've got an extra line for some reason. What's that for? Nothing. So then what we want is a line, the center line here. And we're going to push in a single bolt. We'll do it. So it's going to be M5 again. We need to push that through all the way. That's going to be quite clever to do. We're going to push that through all the way out of here. We can do it. Push it all the way to there. Hasn't come through. So what we'll do is undo that, push it all the way out like that. That's weird, isn't it? Strange. I know what to do. Let's get rid of these lines a minute. Let's try and come the right way up. Is that the right way up? Yeah, that's the right way up. Right. So we're out of there. We don't need X-ray now. Let's come out of X-ray mode. So there's our thing that we need to get rid of. So there's no intersection with the model, so can I intersect it with the model? Oh, there might be. So what happens if I can I? No, I can't do it. So what I'm going to have to do is flatten this area here, really. Let's just flatten this area. Oh, what am I putting that in for? Needs to be this. Okay, so we've got that there. Is this going to let me push it through? Yes, it let me push it through. That's okay, we'll have a bit of a thing there. Let's push this down to level with this. So we've got a bit of a weird one. Got our hole, and we've got some kind of weird surface here. Oh, we've got another line. Where's that come from? Oh, we have got that there, and we've got a surface, so we could just get rid of the surface. And we've got a hole, and we need to countersink it, so the cap head disappears completely without touching the tube. We've got 12mm, so we can do that. Right, the cap head, we'll give it plenty of space. Give it plenty of space. How far do we go? Let's just say, I don't know, let's say 3mm. Alright. So we've got it there. It's not part of the model. So can we make it part of the model? Intersect the faces with the model. Yeah. No. No. It hasn't done it. Right, undo, intersect. If it didn't work, it didn't work. Ah, we need to take it off and put it back on again. That's what we need to do. Not that one now. So we cut it. Paste it in place. Cut it. go in and paste it in place. No, it still can't do it. Okay. Undo paste. What's the matter with it? Ah, sticking up, see? This bit of the hole's not right there. Okay, now it's flat, we'll just get rid of that hole altogether. Just get rid of that hole altogether. Gone. No. I just want that bit. Hang on. Let's get rid of it. Why has it got rid of everything? What have I done? Is there no surface there? No, there isn't. Let's take that away and put back the surface. Alright, now we've got our surfaces back again. They're the wrong colours. We can sort that out there though. I don't know what colour they are, they're just black, aren't they? Hang on, let's just find out what that colour is. It's the one next to that. Okay. One next to whatever that is. I don't know, I've lost track of it. Right, it doesn't look right, does it? Oh well, we'll colour it again, I don't know. It's in 3D. Right, let's find the centre again. Let's find the centre. There's the centre of that, and there's the centre of that. Oh, it's rocking around. Right, so it's rocking around. I don't quite know why it's rocking around. Oh, because I find it very difficult to move in and out here. So I'm in the tube, aren't I? Right, I'm actually in the tube now. God, get out of the tube. I don't want to be in the tube. Right, so we've got our surfaces. Let's try again. So we want that like that, and that like that. That's better. 2.5. Okay. We don't need X-ray anymore. It's gone very dark now. We've done something wrong. We're on the wrong colour, that's it. Right, no, is that even worse? It is, isn't it? I think it should be on textured paint. I ain't got a clue. Okay, we'll just don't know what we'll do. We'll just go and get it back again. Synthetic surface. That. Is that it? Yeah. Alright, we're back. So now we want... Right, we need it. It's not letting me do it. A shoulder now. Come on, it's not supposed to be this difficult. 3mm. And pocket it down. How far down? I suppose we've got to go to there. What's the size of that between there? 5mm, that's enough. Get rid of these lines now. Okay, so we've got the bottom bit and it spans the 40mm extrusion, and the cap head screw will be inside out the way of the tubes. There's no chance of it smashing the tube. Right, we've got something weird going on here though. Oh, that's our original oil. Why is that like that? It's weird. Strange, very strange goings on here. Alright, that's better. That's better, yeah, that's it. Okay. Right. Okay. Why's all that fuzzy there? Oh, it's just the graphics. Right, let's come out of that. So we've got our two pieces. Now the problem is I can't mill out. I can't mill it out. I can only mill it out flat, so I can't do that. So looks, might have to 3D print this, you know. It's okay. It gives me excuse to get my 3D printer built and 3D print something for once. Yeah, I can mill out a round band unless I do it in sections. I could mill that out and then you just do manual drilling and countersinking. Don't like the idea that much. Not manual because it puts room for error. Anyway, that's in the right place now, so just get rid of that. Okay, so we've got both of them in the right place now. What have we got here? Oh, so those lines I put in earlier. Right, so those brackets now will be clear of the carriage, just about. Just enough. Yeah, that's fine. That's fine. I mean, they could be rotated around up here, really, and that one could be put down there or left. Just I don't know. I could make a clip mechanism. I don't know, something else, or just buy some, or use the ones off the K40. Anyway, that's gonna be it now, I think. For now, that's it. So that was the only thing we got to worry about. Now I've got to put that back, and I can't remember the length of it. So the best way is to do it this way, from above with the cutting area in place. Grab that assembly and just move it across. Oh, it's not going to work, is it? I need to view the rest of the model. So grab it from there, move it over like that, and just stop it there. Something like that. That's it. Alright, so that's it, yeah. What's going on here? It's back on the bump. And the wheel, what's the wheel doing? The wheel, I can't see, it's running out of screen. The wheel is above the aluminium and the nut's not touching it, so it's fine. Yeah, it's fine. No problem, no problem. Okay, that's it then. So back to as he was. Yeah, that'll do. So we've done the limits. That's where we put the limits. There and there. All the wiring. That wiring goes through this channel up to the end. This stepper motor and the limit, the X limit switch wire goes along the channel here, all the way up to, all the way underneath there into this drag chain and round over there. This air assist and laser pointer and stepper motor goes in there, all the way over to there, down here, round the back, and then through this drag chain and out there. And all the other wire, everything else comes to this bulkhead here, to the controls bulkhead. Right, that's it then. Hopefully the weekend I'll have the rest of these pieces. I'll order in a bit those spaces that I'm missing. These spaces. I only need 12 spaces, isn't it? 12. Okay, so that's the end of this one. Just got to be building some stuff next. Yeah, I think that's okay, everything's good. Rear lid. Right and front lid. Oh, that's the other part of the model. Yeah, so I've got two designs. I don't know if they still work. There's probably stuff that needs to be moved. See, yeah, that stuff there needs to be grabbed and grouped. Is it separate? Hang on. No. So I need to grab all that. It contains lots of other stuff, doesn't it? Hang on. There's lots of bits need to be. Yeah, those switches and that, they need to be. Right, so let's take the panels off a minute. I thought we'd finished, but we haven't. Alright, so design B. So switches have got to be put onto something. So that switch has got to be cut and put onto this gantry. Bolted in place. Anywhere there, paste in place. Right, so that comes out. Then this one, that one's got to be cut and put on with this frame. Yeah, paste in place. Okay, so when I turn off design B, what we got? I cannot hide the layout. You're right. Hang on. So design B, there's still something left. Oh, that bit. Those bits have got to be cut and put in. Got to be part of the mirror assembly. Oh, or this bracket. Probably the mirror assembly. So let's paste it in place. Okay, so when we turn off design B, so there's something I noticed up this end, the drag chain. This drag chain needs to go in. Actually, there's more drag chain. So there's drag chain Y. There's 2 of them. So they've got to be cut. Design B, and now they're paste in place. Where though? So it's all of that, isn't it? Yeah. Paste in place. Okay. Right. So now if I turn off that one and design B, everything's gone, and I can bring design A back. There's design A. Yeah, so we're okay. Design A off, design B back on. Covers back on. Oh, panels. Yeah, the panels are rogue, aren't they? I turn design B off. Let's just group them and put them in design B. That's it. So design B, design A. Everything there. I think everything's there. Yeah, everything's there. Okay. That's it then. That's it for today. Got to model some switches and meters and whatever else is going to go in it at some point. So let's get the covers off. Covers, where are you? Where's the covers gone? Panels. Let's zoom in over here. Let's zoom in over here. Right, let's find these switches. Couple of... What happened? Oh, that's annoying, isn't it? Right, okay. That'll do. Just a little bit over. Go on, a little bit over. That's it. Shrink it down. Oh no. What the hell? Oh, I just want the switches. Just want the switches like that. And the stepper motor and the drag chain in the view. Something like that. Okay, that's it. That's the next thumbnail. Alright then. So that is going to be it. Let's get out of here and do something else. Thanks for watching. Bye for now.
This constitutes all available data. That information is not available.
If you didn't want the answer, you shouldn't have asked the question.
That is better. Our relationship will be best served if your statements are free of ambiguity.
My interpretation of the data leaves little room for error.
You know what they say. No good deed goes unpunished.
It is an immutable certainty.
I am checking. Kindly wait. I have the information you require. I must assume that your request is a frivolous one.